Welcome to, I guess, this whole event around ETCC, where we're going to be talking about like a little bit of MEV and how validators see it, how liquid restaking or liquid staking sees it. Also, I'm going to talk about base rollups. But the title of the talk is Base Rollups and Execution Tickets. I'm going to give a little quick background of like how the entire like ecosystem was shaped around this. Also going to give a quick background about like how Puffer works and what Puffer is in general. So without further ado, I'm going to get that started. So this has been I don't know if anybody's been closely following crypto Twitter for the past maybe 2 weeks, 3 weeks. There has been some heated / spicy debates around base rollups, around pre-confirmations. I'm going to unpack those in this as well, which features Puffer's Unify, one of our own sort of like stacks around base rollups. And we'll get things from there. So first of all, an introduction to Puffer. How Puffer works, how Puffer came out to be. We're the first permissionless liquid restaking protocol. Why we're permissionless? Because anybody can run an Ethereum validator on top of Puffer as long as they have the requirements met. Our goal was always to make running an Ethereum validator more viable to the users. That's where we tapped into restaking as well. And as you can see in the diagram, we also do paid with restaking rewards to the node operators themselves as well. Of course, a lot of you got to say, like, the payments haven't been live on Eigenlayer or anything, but we hope that goes live very soon in August, and we can also start paying rewards to the node operators as well. In return, to ETH stakers, we give them a receipt token that is liquid that they can trade. That's PuffETH. That's the birth of the LRTs, and that's our Puffer LRT flywheel. Now you might like think, oh no, just another L2. Base rollups are just another scheme around L2s, and Puffer Unify is just going to be another L2. But the fact that it's something else and it's going to solve many problems that exist today on Ethereum is what excites us to actually present this today. So let's cover up a little bit how rollups work today. Essentially, there is a centralized sequencer in the case of the entire rollup stacks today. I know there has been talks about shared sequencing or decentralized sequencing, but a user, after sending a transaction, which is very cheap these days, to a centralized sequencer, they do get this very fast. In case of Arbitrum, I think it's 300 milliseconds or 400 milliseconds, or it might be 200 even. They get a soft confirmation that, hey, your transaction is going to be included in the Ethereum blocks, which goes to the data availability layer. And that's essentially how rollups today work. But what problems have they created today? There's, of course, this centralization risk. The sequencer can start censoring your transactions. They can also potentially extract toxic MEV from their users. And that has been the main issue like of concern today. But like, I guess the only defending point for these centralized sequencers are just like, my operator is reputable. I have fancy VCs. I'm a VC chain, so I'm not going to front run you. I'm not going to like screw you over. I'm not going to censor you. However, there are talks about L2s starting to censor, which is not good. That's not what Ethereum is about, and that's not good. Another negative sum game is each of these L2 stacks have started creating their small liquidity islands. Either I'm building my own stack, I'm building my own super chain, and all of these like stack is going to be interoperable only within itself, which means they're building these liquidity fragmentation and these islands of liquidity that are a negative sum game for the end of the Ethereum. At the same time, now we can talk about economic alignment with the L1. If ultimately the MEV, which is a big part of the execution rewards, is getting captured by these centralized sequencers, it means that Ethereum L1 block proposers are going to end up walking away with less MEV, which means running a validator is going to be less viable on Ethereum, the main problem we wanted to solve for, and therefore would risk the ultimate security of the chain, risk the ultimate security of like decentralization of the chain as well. So that's the problems we have today with rollups, and we need a solution for that. How can we solve it? This is like what I talked about essentially. Like we're trusting this soft confirmation, which can be censored. Also, there is a liveness issue and MEV issue as well, because there's one sequencer. If it goes live, if it dies, that's basically it. It can cause liquidations. So these are again some elaborations around how this liquidity fragmentation can go. So let's imagine there is a world that Curve has their own sort of roll-up, or Curve is on a roll-up. A user sends a transaction to Curve. They get a receipt token, let's say an LP token that they can use in lending, but they cannot communicate in Aave. They cannot go to this island of Aave that built their own liquidity on their own rollup, maybe on another stack. And at the same time, this is the issue of the MEV being captured by the centralized sequencer, because they would be organized and building blocks. They would be putting these transactions together that the user is sending on the L2, and therefore they would be able to walk with the MEV. We want MEV today to go to the L1, basically validators. I think that repeated, but okay. Now, based rollups. Maybe I'll start by talking about how interoperability was going to be achieved by these L2s. There were many ideas how to interoperate between the app chains. One of the solutions was use a shared sequencer. I'm going to save you the headache of like going through snarks and other things. But imagine OP stack is going to get one computer or few computers, 4 out of 5 computers that are going to sequence all OP superchains transactions. They would be able to share data, of course, at the cost of more money, spending more money, to be able to interoperate these superchain chains. That's where the shared sequencing was born, and the idea was good. But imagine what if our shared sequencing layer becomes the entire Ethereum validators. If we move to this level of shared sequencing, we get to what we call based sequencing. Based sequencing can ultimately enable all rollups to talk to each other, regardless of what stack it is, regardless of like what technology they use, ZK provers, like, or some other technology that they use. Of course, global synchrony is achieved once we get to those snark provers and like these fancy proofs. But the idea at today is if we would solve for the problem of liquidity fragmentation, we start using the shared sequencer of the based L1. So the flow would pretty much look the same. An L2 transaction comes to these Ethereum validators. Using the concept of pre-confs or pre-confirmation, they would be able to get a very fast response of, hey, I'm going to include your transactions. We need to open a little parenthesis here and explain what pre-confirmations are. Pre-confirmations are a stronger commitment than soft confirmations. Essentially, we say this is a collateralized commitment to the user for their transaction to be included in certain slot within a block. If you remember, in our centralized system, the soft confirmation was coming from the centralized sequencers. You're telling the customer, I'm going to include your transaction, don't worry. But this has to be done in a trustless manner. Therefore, it has to be collateralized. This is where the credible neutrality comes from. This is where the sequencer cannot censor the transactions anymore. And at the same time, the biggest part about this is the MEV is going to go back to the Ethereum layer 1. That's where economic alignment comes from. Now let's simulate again our scenario. A transaction is hit our curve. Now we can interoperate with whichever base chain or based app chain that Aave is sitting on. And also it can hit at the same time on Uniswap. Let's say a liquidation hit Aave. Uniswap people want to be able to trade against it or like be represented in that. So it goes and shows up on the Uniswap chain as well. Most important thing, again, MEV goes back to the based sequencer. Who are the based sequencers? They're the Ethereum validators. So that's where Puffer Unify comes in. Not gonna dive super deep into this, But essentially, we are going to have a pre-conf architecture, whether it's going to be an eigenlayer service or just a simple smart contract service. It's still up for debate. Many teams are designing pre-confs today, so we're going to be actually like talking to them to actually design this. The Puffer Unify, like essentially roll-up stack, is going to help us create this future of app chains in the future, so people can talk and apps can talk. Very interestingly, actually, an important item that recently, like after talking to many apps or major, like you can call them blue chip projects, their requirement is actually around composability with layer 1 as well, which really gives more credibility to these ZK rollups or ZK stacks that are coming in the future, so we can achieve the composability that we need. One massive misconception too, like a lot of existing L2s are worried that they're going to make less money. My congestion fees are going to go to the L1 sequencer, and therefore I'm not going to be able to make much money, so I'm not going to choose a base rollup compared to an OP stack. So that's a misconception, and I believe that I can talk more in depth into that with anyone who has a question about this, but congestion fees maintain the same, and anybody who does a based app chain gets to walk away from the same congestion fees. In an ecosystem where everybody is using Puffer Unify based app chain, like everybody would be able to walk away with the synchronous composability. Okay, the storm just hit. Didn't expect that one. And essentially, like, let's say in the future, like I mentioned, a Curve, an Aave, or anybody who would like spin up their own app chain would be able to walk away with the composability that is much needed. Why? Let's not forget why we moved to rollups. It was saving cost, and it was the longer block times of Ethereum itself. Now we're doing like the 200 millisecond transactions here. So we're getting like orders of magnitude faster while keeping composability and credible neutrality. So maybe let's discuss the future user experience, both on the developer side and on the user side. The developers are going to have low friction. They would be able to just use Solidity Stack, and one of the things that they're most familiar with, there's low maintenance. Smart contracts are composable with everybody else. So smart contracts can translate to app chains, and they can also capture their own congestion fees, the one thing that they might have been worried about. Users are going to just not have to really go through this massive painful UX that they currently have to go across chains to take advantage of like essentially the chain transactions. And ultimately what is very important to many protocols is this credible neutrality that they're getting, including ENS. Let's say ENS wants to go essentially like on a rollup because they want to save gas, and they don't want to be censored. They wouldn't want to be censoring their users. So that's very important. So this is ultimately like a depiction of what Puffer Unify would look like, where the shared sequencing layer of all Puff app chains or Puffer app chains are going to become the Puffer validators themselves. So there's a bonus slides. Like this is like such a big topic to unpack. It's called attester proposer separation. If I have like few minutes, I'm going to jump in and like talk about it like very quickly. Do I have time? Cool. So since we're talking MEV, and this has been a topic of research for quite a while, I feel like ever since early 2024, after the last Columbia Crypto Economics event in 2023, this has been like a big topic of actually like debate. What is attester proposer separation? As the name depicts, we want to separate attester duties with proposer duties. We want to tell attesters, okay, you can just do attestations. Proposers, you can do this. There are now different ways to implement attester proposer separation that has been actually proposed by the community of the researchers. Execution tickets, execution auctions, and many more that came out. I would not really dive into the ticketing system, but the idea is Users go ahead and do their attestations. Essentially, validators do their attestations as they are doing it today. However, proposals are going to either be done in an auction matter, or they're going to be done in a ticketing matter, where it's like a sort of a lottery, and after they purchase some tickets, they get to propose. What is this construct solving for on the Ethereum in protocol if it gets enshrined is it really provides this MEV smoothing. We're going to be seeing way less spikes across the MEV map, which creates like much better UX once this comes to the user experience on the stack. One of its initial motivations to do this was battling the timing games. If you're not familiar with MEV timing games, it's essentially this simple. Instead of a proposer proposing their block within the 12-second window, they wait till absolutely the last millisecond that they can propose a block to walk away with the maximum amount of MEV. This battles the timing games as well. And of course, this prepares the protocol for the end game of staking, which is like capping staking, because we don't want to walk away with a protocol that its entire assets are staked. That's the trajectory that we see today thanks to staking and restaking. How did we implement APS in Puffer? Currently, to smoothen out MEV and also like avoid the problem of rock pooling, which comes from the trustless validators, we implemented validator tickets. It also in Puffer v2 in the future that we are gonna full force enable a tester ticket and proposer tickets on our staking stack. It's gonna create much better rules, and it's gonna enable better rules around our pre-confirmations and also provide us with much more guarantees around the pre-confirmations that come out of the Puffer protocol itself. Yeah, thank you so much all for staying through all this talk. This is our socials. You can follow us. We recently announced Unify. If you would like to follow us and talk to us, do so. Scan the QR code as well. Last but not least, we are also hiring. So if you're passionate about protocol design, protocol development, research, just let me know. I'm right here. Thank you. Should I take questions or? Okay. Anybody has questions?